Imagine looking up at the night sky tonight, and suddenly the moon is gone. Not covered by clouds. Not hidden behind an eclipse. Not slowly moving away. Gone. Completely. For exactly 24 hours. Then, just as suddenly as it disappeared, it comes back. At first, this might sound like a strange but harmless event. After all, the moon is about 384,000 kilometers away from Earth. It doesn't produce its own light. And compared to the size of our planet, it looks relatively small. So what could possibly happen if it vanished for just one day? Would the oceans stop moving? Would the Earth fly out of orbit? Would humans notice anything at all? The answer is surprisingly complicated. Because the moon may look peaceful and distant, but its influence on Earth is much stronger than you might think. So let's imagine that, at exactly midnight, the moon suddenly disappears. And let's see what happens. 1 hour later. 6 hours later. 12 hours later. And finally, when the moon suddenly returns. The first thing we would notice, the night sky. The first and most obvious change would be the night sky. Without the moon, nights would become dramatically darker. The full moon can illuminate the landscape so brightly that, away from city lights, you can sometimes see your surroundings clearly. Without it, the natural night would return. Stars would appear much brighter. The Milky Way would become easier to see. And in places far away from cities, the sky could become breathtakingly beautiful. But humans wouldn't be the only ones affected. Many animals use the moon as a natural clock. Some species use moonlight to hunt. Others use it to avoid predators. Some animals even time their mating and reproduction cycles according to the lunar cycle. Sea turtles, for example, rely heavily on natural light when they hatch and move toward the ocean. Marine animals also respond to changes in moonlight and tides. So one moonless night could temporarily confuse many creatures. But for most animals, one day without the moon would not be enough to cause a global ecological disaster. The bigger changes would happen somewhere else. In the oceans. The oceans would begin to change. The moon is famous for controlling Earth's tides. But how exactly does that work? The answer is gravity. The moon's gravity pulls on Earth. Because the oceans are fluid, they can respond to this gravitational force. This creates tidal bulges. As Earth rotates, different locations move through these bulges. And that's what produces the familiar cycle of high tide and low tide. The sun also affects Earth's tides. But because the moon is much closer to Earth, its influence is stronger. Now imagine the moon suddenly disappears. The first thing that happens is not that the oceans instantly become perfectly flat. The oceans have enormous inertia. Water is already moving. Waves are already traveling. Currents are already flowing. So the existing tidal motion would continue for a while. But the gravitational force that creates the moon's tidal influence would suddenly be gone. The result would be extremely unusual. Tides would become much weaker. But they wouldn't disappear completely. Why? Because the sun is still there. The sun also creates tides. So even without the moon, Earth would still experience solar tides. They would simply be much smaller than the tides we normally experience. This means coastal regions around the world would experience an unusual tidal cycle. Some areas might see much lower high tides. Others might experience unusual water movement as the oceans adjust to the sudden change. But here's something important. The oceans would not suddenly rise into the sky. And they wouldn't suddenly drain away. That is one of the biggest misconceptions about the moon disappearing. The change would be significant, but it would not instantly destroy every coastal city on Earth. Would the Earth stop rotating? Now let's get to one of the biggest questions. If the moon disappeared, would Earth suddenly start spinning faster? The answer is no. At least, not noticeably in one day. The moon's gravity has a long-term effect on Earth's rotation. Over billions of years, tidal friction has slowly transferred energy from Earth's rotation into the moon's orbit. This is one reason why Earth's rotation has gradually slowed over geological time. And it's also why the length of a day has increased. But this is an extremely slow process. If the moon disappeared for only 24 hours, Earth's rotation would not suddenly speed up. You wouldn't suddenly experience shorter days. Your clocks would continue working normally. The Earth would keep spinning. The atmosphere would keep moving. The winds would continue. And you probably wouldn't feel anything at all. In fact, if you were standing outside, you might only notice one thing. The sky looks strangely empty. What about Earth's orbit? Now things get even more interesting. The Moon doesn't just orbit Earth. Technically, Earth and the Moon orbit a common center of mass. This point is called the barycenter. Because Earth is much more massive than the Moon, the barycenter is located inside Earth. But Earth still makes a tiny orbital movement as the Moon travels around it. If the Moon suddenly disappeared, this movement would stop. Earth would immediately follow a slightly different path around the Sun. But again, the difference would be incredibly small. Earth's orbit around the Sun would not suddenly collapse. The planet would not fly away. And we would not be thrown into space. The Sun's gravity is vastly stronger than the Moon's influence on Earth's overall orbit. So for one day, the difference would be almost impossible for humans to notice. However, there is another interesting consequence. The Moon is not just a passive object in space. It also helps stabilize Earth's axial tilt. And this is where the story becomes much more dramatic. The Earth's tilt would become less stable. Earth is tilted. Our planet rotates around an axis that is tilted by about 23.5 degrees. This tilt is one of the main reasons we have seasons. When the northern hemisphere tilts toward the Sun, we experience summer. When it tilts away, we experience winter. The Moon's gravitational influence helps stabilize this tilt over very long periods. Without the Moon, Earth's axis could become much less stable over millions or even billions of years. But here's the important part. If the Moon disappears for only one day, nothing dramatic would happen to Earth's tilt. The planet would not suddenly tip over. Summer would not instantly become winter. The oceans would not flood the continents. And the seasons would not suddenly change. The Earth is massive. It has enormous angular momentum. Its rotation axis cannot simply swing wildly from one day to the next. So a 24-hour disappearance would have almost no immediate effect on Earth's axial tilt. But if the Moon disappeared permanently, that would be a completely different story. What if the Moon never came back? Let's pause our 24-hour experiment. Imagine that the Moon didn't return. At first, the changes would still seem relatively small. The nights would remain darker. The tides would become weaker. Many animals would gradually adapt. But over thousands, millions, and eventually billions of years, the effects would become much more significant. The Earth's tides would become much weaker because only the Sun would remain as the main tidal force. Coastal ecosystems would change dramatically. Many organisms depend on tidal environments. Tidal pools would behave differently. Intertidal habitats would shrink. Marine ecosystems would slowly reorganize. The Earth's rotation would also evolve differently. Without the Moon's tidal braking effect, the long-term slowing of Earth's rotation would be reduced. That means Earth's days would remain shorter than they otherwise would have been. And perhaps most importantly, Earth's axial tilt could become less stable over geological timescales. The climate could experience much larger changes. The planet might still remain habitable, but Earth's environment could become far less predictable. Fortunately, that's not our scenario. We're only talking about 24 hours. So let's return to our experiment. The Moon has been gone for 12 hours. Half a day has passed. And now, something strange is happening. The world would become extremely dark. It's now nighttime on one side of Earth. Millions of people look up. And the Moon is still missing. For most people living in cities, the difference might not seem dramatic. Streetlights, buildings, cars, billboards, all of these create artificial light. But far away from cities, the difference would be enormous. The natural night sky would become much darker. Astronomers would love it. Telescopes would have less interference from moonlight. Faint galaxies would become easier to observe. Meteor showers would become more visible. And the Milky Way would appear brighter. For professional astronomers, This could actually be an unexpected gift. One completely moonless night would create excellent observing conditions. But there would be one problem. Nobody would know what happened. Imagine being an astronomer watching the moon disappear. You would immediately start asking questions. Was it an astronomical event? Was it an optical phenomenon? Did something collide with the moon? Or did the moon actually disappear? The scientific community would probably be in a state of panic. Observatories around the world would point their telescopes toward the empty region of space. Satellites would search for evidence. Space agencies would begin analyzing the event. And billions of people would be watching the sky. Social media would explode. Conspiracy theories would appear within minutes. But scientists would quickly discover something even stranger. The moon wasn't destroyed. It was simply gone. The moon's absence would be detected everywhere. Modern technology makes the moon's disappearance impossible to hide. Satellites constantly monitor Earth and space. Space agencies track the moon's position with extraordinary precision. The moon's gravitational influence can also be measured. If it suddenly vanished, scientists would immediately notice changes in gravitational interactions. The moon's disappearance would be one of the most extraordinary scientific events in human history. Every observatory would be watching. Every space agency would be investigating. And every scientist would be trying to answer the same question. Where did it go? But assuming the moon simply vanished without causing any explosion or debris, the Earth would continue its journey around the Sun. The planet would remain intact. And life would continue. Then, 24 hours would pass. The moon suddenly returns. At exactly the same moment 1 day later, the moon reappears. Instantly, the night sky lights up again. The oceans begin responding to its gravitational influence. The tides start adjusting. And the world suddenly has its moon back. But would everything immediately return to normal? Not exactly. The oceans would need time to readjust. The tidal system is enormous. The water in Earth's oceans has mass. It has momentum. And it takes time for large-scale water movements to respond to changing forces. So the return of the moon could create unusual tidal behavior. Depending on exactly how the disappearance happened, coastal regions could experience abnormal tidal patterns as the ocean system readjusts. But again, this would not mean gigantic walls of water destroying every coastline. The real effect would be more subtle. Tides might behave strangely. Coastal ecosystems could experience a temporary disruption. Animals that rely on lunar cycles might become confused. But within a relatively short time, the natural system would begin returning to normal. The moon would once again dominate the night sky. And for most humans, life would continue almost exactly as before. So, would humanity survive? Yes. Absolutely. If the moon disappeared for exactly 1 day and then returned without any other catastrophic event, humanity would survive. Earth would survive. The oceans would survive. And the planet would continue orbiting the sun. There would be no instant apocalypse. No sudden explosion. No planet-wide earthquake. And no dramatic change in gravity that would send humans flying into space. The biggest immediate effects would probably be darker nights, weaker tides, temporary disruption to animals and marine ecosystems, and a massive scientific mystery. But the most fascinating part of this thought experiment isn't what would happen during those 24 hours. It's what the moon does for us every single day, without us even noticing. The moon is more important than we realize. The moon is often seen as nothing more than a beautiful object in the night sky. But it is deeply connected to Earth's natural systems. It influences the oceans. It affects tides. It helps stabilize Earth's rotation axis over geological timescales. It influences animal behavior. It has shaped human culture for thousands of years. Ancient civilizations used the moon to measure time. Calendars were created based on its cycles. Farmers watched its phases. Sailors used it to navigate. And humans have always looked toward it with curiosity. The moon has been with Earth for billions of years. It has witnessed the rise and fall of civilizations. It has seen dinosaurs walk across the planet. It has watched continents move. And it has been in the sky throughout almost the entire history of humanity. So if it disappeared for just one day, the world would probably survive. But we would suddenly realize something. The moon is not just a decoration in the sky. It is part of Earth's system, a silent companion, a gravitational partner, and one of the reasons our planet became the world we know today. The final question. Now imagine this. You walk outside tomorrow night. You look up, and the moon is gone. No crescent, no full moon, no familiar bright circle. Just darkness. At first, you might think nothing has changed. But somewhere across the planet, the oceans are behaving differently. Animals are responding to a missing signal. Scientists are staring at their instruments. Astronomers are pointing telescopes toward an empty patch of sky. And billions of people are asking the same question. Where is the moon? Then, exactly 24 hours later, it suddenly returns. The moon appears exactly where it should be. The tides begin to adjust. The night becomes brighter. And the world slowly returns to normal. But for those 24 hours, humanity would experience something almost impossible to imagine. A world without the moon. And perhaps the strangest part is this. The moon could disappear for an entire day, and Earth would still survive. But if it disappeared forever, our planet would slowly become a very different world. So the next time you look at the moon, remember, that glowing object in the night sky isn't just something beautiful to look at. It is part of the invisible machinery that keeps our planet moving. And if it ever vanished, even for just one day, we would finally understand how important the moon really is.